Hey, it's Dr. J. We're going to finish chapter 5 today, section 5.8, the Pythagorean Theorem. Probably one of the most famous mathematical theorems. Even people that may not have studied mathematics extensively have probably heard of it. I was watching Jeopardy the other night, and it was a question on Jeopardy. So it's a very, very popular theorem, attributed to, although nobody really knows whether Pythagoras was in fact the inventor of it, but oftentimes in mathematics, theorems and formulas get named for the wrong person, but it's attributed to Pythagoras of Samos, who's a Greek philosopher and mathematician. He was from the island of Samos, which is a Greek island. I believe it's in the Aegean Sea. And I have his dates here. He's very old. 570 BC, or BCE, before the Common Era. And it's believed that he died in 495 BCE. That's a whole other story. It's quite an interesting story if you ever are interested in reading a little ancient Greek history. This is from about 2,500 years ago. So anyway, I just thought I'd share that with you, but this is definitely not going to be a history lesson today. We're going to get into the theorem and the mathematics behind the theorem. So without any further stalling, I will go ahead and quote the theorem. So there's a lot of terminology in this section, so I'm going to start off with some of the vocabulary, and I'm going to write out the theorem as it is known as the theorem of Pythagoras. And so what does it say? It says a triangle is a right triangle if and only if the square of the hypotenuse, I'm spelling that right. I'll be spelling it a lot today, so I'm pretty sure that's right. The square of the hypotenuse is equal to the sum of the squares of the other two sides. So that is the theorem of Pythagoras. I don't know how to say it or how to write it in Greek, so I'm writing it in English. So there's a lot of terminology we're going to get to right away. I'm sure everybody already knows what a triangle is, right? A triangle is a three-sided shape. Okay. Lots of different ways to draw a triangle. These are all examples of triangles. Okay. We say it's a right triangle if it has a 90-degree angle. This is called a right triangle. So right, 90 degrees. Yeah, so if one angle is 90 degrees, the square of the hypotenuse. Now we are going to be doing square roots. We just finished a lesson on square roots, 5.7, so we will be doing those today as well. But when I say square, I mean exponent square, which we will then follow up with a square root later. But in this terminology, I mean square, exponent square. Of the hypotenuse is the longest side of the triangle. Let me use a different color for that. The hypotenuse is the longest side of the triangle. Okay. So the hypotenuse, here's a lot of different examples. If an angle is not right, if it's not 90 degrees, we use just a little curved angle symbol to mean it could be any angle. But if it is in fact 90 degrees, then we use a square in the corner. It doesn't necessarily have to be the lower corner. It could be the upper corner. It could be the bottom. It could be any of the three corners. So the hypotenuse is the longest side. Longest side. Okay. All right. And then the other sides are called legs. So we call this a leg and a leg and a hypotenuse. Hypotenuse. All right. These are terrible examples, so I'm actually going to erase these two. I was just showing you in general what the shape of a triangle is, which I'm assuming that is already obvious. Okay. So we have names for these legs. Let me go ahead and draw a much nicer triangle here. The two most common ways to orient a right triangle is putting the right angle in the lower left side, or sometimes we put it in the, my camera is a little skewed, so it might not look square, but believe me, it is. Okay, so we call this the hypotenuse, C. These are the standard letters for a triangle. We call this leg B, and we call this one over here leg A. All right, so this is the base leg. This is the alternate or other leg, or altitude. So people remember it as altitude, A. All right. And then the hypotenuse is always C. So this theorem says a triangle is a right triangle if and only if the square of the hypotenuse, C squared, that's the square of the hypotenuse, is equal to the sum of the squares of the other two sides, also known as the legs, B squared plus A squared. Now, if you've had math before, algebra, perhaps high school, perhaps another college algebra class or pre-algebra class or something like that, even an arithmetic class, you might not have seen it this way. The most common order is alphabetical. A squared plus B squared equals C squared. If you were to Google the Pythagorean Theorem, this is probably the way you would see it on Google. I actually write it backwards. I do C, B, A, reverse alphabetical order, and you'll see why when I start getting into the examples. All right. I won't be needing my calculator right now. We'll be doing, well, I might need it, but I'll keep it handy. Okay. So that is the Pythagorean Theorem. I will show you lots of different organizations or orders of these terms. The most important thing is that the hypotenuse must be on its own side. So C squared is always either on the right-hand side or it could be on the left-hand side. A and B can be interchanged. We frequently will reverse the order of A and B, and because you're adding them, the order of A and B does not matter. Can be reversed. We call that the commutative property, remember? The commutative property of addition that we learned earlier in the semester. Okay. My pens want to roll around on me. I'm going to put them over there. All right, so let's get started with some problems. Keep this formula in mind. Example 1. Determine which triangles are right triangles. So we're going to use this theorem to determine if a triangle is a right triangle. And then for the rest of the lecture, after we've determined it, we will just only focus on right triangles for the remaining part of the lecture. So let me do a couple different examples. Let's do a very standard order, something like this. All right, now, because I don't know whether it's a right triangle, I will not put the square in the corner until I determine whether or not it's a right triangle or not. So let's do 9, 18, and 16 for that one. But then I want to give you some variety here. So we're going to go like this. I don't always want to draw every triangle in the same order. Okay, so let's do 5, 13, and 12. And let's do one more. So we'll do 3 altogether. Let's see if I could fit one down here. That's terrible because the angle is all. So these are the two most common orientations of a right triangle. I don't know whether it's right or not, so I can't do that yet. If it turns out to be right, then I will change one of these edges to a square. How about we'll make this one a little bit larger. Now these drawings are not to scale, so this will be 28, 45, and 53. Okay, so let's go ahead and get started. The hypotenuse. The hypotenuse is always the longest side, so that's your C. Let's do one at a time. We could go ahead and identify them all. Who's the C? So that's the longest side. That's C. Over here, the longest side is C. Now, there are some special cases that we'll get to towards the end of the lecture in which there might be two sides that are the same. It's called an isosceles triangle. I'm not quite there yet, so I just want to let you know for the first, probably hour or so, all the triangles will be what are called scaling or right. Well, hopefully they're right. Some of them might not be, in which all of the sides are different. Okay, now remember A and B can be interchanged. I typically do B on the bottom and A on the side, the alternate or the altitude. However, you can do it other ways. You could choose this to be B and this to be A. Okay, remember C has to be C, has to be the longest one, that's the hypotenuse, but A and B can be reversed. But I'm pretty typical in how I do it, and I don't want to make things any more confusing than they need to be, so I'm more than likely, most of the time, I'll do it this way. Okay? All right, so remember, a triangle is a right triangle if and only if the square of the hypotenuse is equal to the sum of the squares of the other two legs, or the other two sides. I might need my calculator for some of these larger ones. Earlier in the semester, I gave you guys a real hard time in my lectures about warning you against using your calculator. But we've got to the point where it's going to become a necessity. All right. And you'll see why I write it this way. So we have C squared is B squared plus A squared. And I'm just checking whether or not this is true. Right? If true. Are these actually equal? So we're going to go 18 squared equals 16 squared plus 9 squared. You could probably do 9 squared in your head, but these other ones typically are not memorized at this level. So 18 squared is 324. 16 squared is 256. I'm going to double check that one because I always forget that one. When I was 9 years old, I memorized all of my times tables, multiplication facts up to 15. 15 times 15 is easy, 225. But honestly, I've been doing this for many, many years, and anything beyond 15, I just use a calculator. 81 is pretty easy. 9 squared is 81. So we're checking, is this true? Is 324 equal to 256 plus 16? I don't think it is. No, it's not. No. Okay. So this is not a right triangle. Right. It looks like one. It almost looks like one. It's pretty close, but it's not. Turns out that this angle is a little bit more than 90 degrees if we actually measured it with a protractor or something. All right, so let's try this one over here. So C squared, that'll be 13 squared, is 5 squared plus 12 squared. This one we can do entirely in our heads. 13 squared is 169. 5 squared is 25. 12 squared is 144. That is true. 169 is equal to 169. So this one is a right triangle. You could just say it's right. Yeah. All right, so that's this angle over here in this corner. I know it's oriented in a funny position, but that is a right angle. And again, my camera's at an angle, so it doesn't look perfectly square, but what I'm looking at, it should be square. Okay. One more. Let's do one more here. This one's definitely a calculator problem. We got 53 squared equals 45 squared plus 28 squared. I can't do those in my head. I mean, I could if I really had to, but I'm not going to. 2809, 2,809, 45 squared. I'm using an old-fashioned calculator I got from Walgreens for $5. You can use your phone calculator. You might actually have an exponent, a square button that does it for you. On these old-fashioned calculators, I'm just multiplying the number by itself. So 28 times 28 is 784. Is that true? 784 plus 2025 is in fact 2809. Yep. So yes, it's true. It's true. It's right. All right. And so that means it's this angle that's the right angle. So the angle that is right, when you verify it, is always the angle that's diagonal or opposite of the hypotenuse. And kind of draw a little guideline there so that you can see which one would be the right angle. All right. This one's not right, so none of these angles are 90 degrees in this particular example. So we have two rights and I guess you can call it a wrong, but we don't call it that. We just say it's not right. All right. So consider yourself introduced to the theorem. This is kind of just the working nuts and bolts of how the theorem works, what it actually tells us about a triangle. For the rest of the lecture, we will only be dealing with triangles that are in fact right. Okay, so example 2. This is now getting into the world of algebra. Geometry and problem solving is now kind of lapsed over into algebra. And so we're going to be finding the unknown values. So find the length of the hypotenuse. So it'll be an unknown value. The length of the hypotenuse. And this is how I will draw most of these triangles. I think it's funny that we call it a right triangle, but look where I often draw it in the left-hand corner. So remember, the word right is just a different version of the word right. We mean true or correct or square. So I don't know what C is, so we'll just call it C, but I do know what B and A are. So there's my B and there's my A. And again, you might memorize the formula a squared plus b squared equals c squared. That's the most common way to memorize it. But that's not the useful way to do it. The useful way to write the formula is to put the c squared first, because we're solving for c. And I usually use reverse alphabetical order. So I'm solving for c. Okay. Now, at some point, I will be introducing a square root, the principal square root only, so there'll be no negative numbers. One way to remember that is just to think of the picture. Yeah, Pythagoras. There's no negative numbers back then. They didn't even know, they weren't even invented yet. Yeah, they didn't have, car loans and mortgages and credit cards and things like that. Although they did have debt, they had the concept of debt. They just didn't use negative numbers. Anyway, I'm getting away from myself now. So we have c squared is, now again, you can choose a and b in either order. Really doesn't matter because you're adding. So I usually just go with 16 is the base and 12 is the alternate side or the altitude. Try not to take the square root too soon. All right, it's typically the very last step is taking the square root. 16 squared, we did that a minute ago. That was 256. 12 squared is 144. Add those up, you're going to get 400. And now take the square root. So you always want to take the square root at the very end to get rid of, or to extract the root. In other words, we call that canceling the exponent. So we have the square root of 400. Now you could use your calculator if you're not sure what the square root of 400 is. I do have a square root button. It's 20. But with a number like 400, you should just be able to do it if it's a perfect square. So C is equal to 20. All right. If it's not a perfect square, then we'll be doing some approximations, but we're just getting going here, so we'll get to that in a minute. I'm going to do one of each. So that one was solving for C. The next one will be find the length of the unknown side, or leg. I'll call it a leg. They're all called sides, but the legs are the A and the B. And I can draw my triangle this way as well, just to have some variety. So this time I don't know what B is. Let's see. Uh-oh, that's 26. I read it backwards. And this is 10. All right. So again, let's start with the standard order, the most popular order, A, B, C order. Yeah. Now, because we're solving for B, I want to have B all by itself. All right, and this is really where you can customize your own, problems, how you do them. The way I do it is I actually rearrange the formula first, and then I plug in the numbers. Okay, but I'll show you both ways. Okay, one way is to move the A squared over so that you have the B on its own side, because that's what we're looking for. So we call that isolating. And then plugging in the numbers now, the known values. So we have C and A. So 26 squared minus 10 squared. 26 squared, that's 676. 10 squared is 100. So B squared is 576. And the square root at the very end cancels out the exponent, and you get B is 24. The square root of 576 is 24. All right. So that's, I often call this prepping the equation. You're preparing it. You're like, you're chopping up the vegetables and getting everything all ready, and then you put in all the ingredients. I always think of it in terms of a recipe. A formula is the same as a recipe. The other way to do it is to not prep the formula. Just use the original formula and just plug in the numbers first. So let's show you that. Let me show you that version. Sometimes we call it the missing side as well. I like to use lots of different terminologies so that every question doesn't read exactly the same way. Oh, I screw up my focus. All right, maybe it'll come back to me while I'm drawing my triangle. So we sometimes call this the missing side. I think what happens is when I show you my calculator, it screws up the focus, doesn't it? Well, hopefully it'll get better. Maybe it's just my glasses, I don't know. All right, so again, the most common form is a squared plus b squared equals c squared. Last time I prepped my equation, I got it organized before I plugged in the values. This time I'll do it the other way. I'll plug in the values now. Come on back, it's too blurry. All right, I'll plug in the values now. So b squared would be 20 squared. That's my b. This is my c equals 25 squared. Some people like this method. It's a little less intimidating because you have numbers right away. A lot of people like the satisfaction of having the numbers right away. 20 squared is 400. 25 squared is 625, but don't trust me, I have made mistakes in the past. Yep, it's 625. Come on back to Earth. I guess it could be worse. My camera has a mind of its own. All right, I'm not gonna let it slow me down. So now I subtract the 400 because I'm trying to get the a squared by itself. All right. It's driving me crazy though. And then I take the square root of both sides. Uh, 225, that's the last one I memorized. I think in 5.7 I recommended memorizing up to 15 times 15 is 225. But if you're not sure, I'd rather have you use the calculator and get it right than try to do without the calculator and get it wrong. Okay, well, sorry for that one being a little bit blurry, but the numbers are there, and we can move on to some more complicated examples. This is at a time where I would normally pause and ask if there are any questions. Remember, you can always email me your questions if you have any, or you can get right into the homework. I often recommend people watching maybe 15, 20 minutes of the video and then get right into the homework. You don't have to sit here and listen to me talk for an hour before you can do a couple of these problems. All right, so the next few examples are going to be a little bit more complicated, mainly because of the instructions. All right. Algebra, right? The most common variable is x. Find the unknown value x. Or sometimes people will just say find x. Oh, that just made it a lot worse. Come on, why me? You know, I turned off my autofocus. I turned it off, but it's still causing me problems. And if I stop the video, I will regret it. There we go. Come on. There we go. Don't mess it up. Perfect, perfect, perfect. All right. So x, we'll just generically use x. It really doesn't change the process. It just looks different because I'm using the variable x for one of the sides. And then I'm giving you the other two sides. Do we already do this one? No. We didn't do this one. Okay. So again, the formula is a squared plus b squared equals c squared, or some version of that. You can also use the c squared equals b squared plus a squared. And then now you just decide which one is x. It could be either, if it's one of these two sides, it's either a or b. The way I'm doing it, I'm calling x b. So x is b. And then 6 is a, and 16 is c. And again, you know, I repeat myself a lot. You can interchange a and b and still get the right answer. You cannot interchange c. C must be c. So I've got, What am I looking for? I'm looking for x. So I've got 6 squared plus x squared equals 16 squared. And if it comes out to be a decimal, I'm going to go ahead and say round to the nearest tenth. I can already kind of tell I'm going to end up getting a decimal as an answer. So 6 squared is 36. 16 squared, there it is, 256 again. All right. Minus 36 from both sides. X squared is 220. 220 is not a perfect square. So when I take the square root, you might like to do it like this so you can see that you've canceled the exponent. Oftentimes people will forget and try to put in the answer where it still has the exponent. That will never work. And then if necessary, you're going to approximate this. So 220 square root is 14.832. All right, et cetera, et cetera, et cetera. Round to the nearest tenth. So my dictator is the hundredth. That's your dictator. Remember from the decimal rounding section. That number is less than 5, so we're going to throw it away. And we're going to keep 14.8 as the final answer. X is approximately 14.8. It's an irrational decimal. All right, so that is one technique. All right. Now, I'll tell you something, now that we're getting more into the nitty-gritty, the algebra of this section. You have a choice as to how you run your problem, it's your show, it's custom. Right? I want you to do it the way you feel comfortable. So I'm going to say find the value of x. Now this time, let's round to the nearest hundredth. Round to the nearest hundredth. Okay. Well, I better draw a triangle, shouldn't I? So how about 10 and 14 and x. Well, you know, I like to draw these mind clouds. There are actually 3 different Pythagorean theorems. Yeah. There's 3, if you think about all the different arrangements of them. This is the one that I originally wrote down when I wrote the theorem out in words. The square of the hypotenuse is equal to the sum of the squares of the other 2 sides. But there's actually 2 other versions. If you're solving for b, then it's c squared minus a squared. And if you're solving for a, it's c squared minus b squared. All right. Now, I don't require you to memorize all of these. In fact, the only one you really need to memorize is the first one. But if you have the first one memorized, or if you prefer the original, these are all a squared plus b squared equals c squared. This is the most common one. All right, these all come from this formula. So this formula can be rearranged in 3 different ways. Okay. Some people go so far as to put the square root in now. I intentionally am not doing that for 2 reasons. One, I don't want to confuse the issue. I want you to know these formulas. And so if I put the square root in now, it almost seems as if I'm, unnecessarily complicating it. So that's one of the reasons. But the other reason is I find that if people do the square root too soon, they end up making lots of mistakes. And my job is not only to teach you the mathematics, but to teach you how to make less mistakes, right? Because I'm pretty familiar with, common mistakes. I make them myself. So anything that you think you've done, I've probably done it more than you have. Okay, especially when it comes to screwing up math problems. I've screwed up more math problems than I can care to share with my audience here. All right, so we are solving for C. Yeah, so we're going to use this one. C is x. Yeah. So we're going to have x squared is b squared plus a squared. You see how nice that is? It's already set up for you to solve. B is 14, a is 10, 14 squared is 196, 10 squared is 100. You're just walking the dog now, right? The problem essentially solves itself. You just have to guide it into place. Now you're going to take the square root of both sides. If necessary, round to the nearest hundredth. That says hundredth. 296 square rooted, 17.2046. So remember, when you're rounding to the hundredth, you go to the thousandth. You always go one to the right of what you're asked. So that's thousandth. Again, that's less than 5. So you're going to say x is approximately 17.20. Some teachers and some people in general would say, well, if it ends in a 0, you don't even have to write it. That's kind of true and false. You don't have to write it, but the instructions say hundredth, so I'm just following the instructions, right? Making sure that I have 2 decimal places. All right. Let's keep these little thought bubbles here and do one more of these before we start doing the word problems. Example 7. Find the approximate value of x. I like to be very specific sometimes. Round to the nearest 10th again. That's the most common one, but I alternate back and forth. Sometimes I'll do tenths, sometimes I'll do hundredths. Very rarely I will do thousandths or something more accurate. Okay, again, you have all these formulas here. Maybe I'll draw the triangle the other way just for some variety. At the beginning, I showed you the triangles in weird orientations. This is one of the more common orientations. Okay, so we got x, we got 19, and 13. All right. So this time, x is a. Yeah. Or it could be b. Right? Remember, a and b can be interchanged, right? Because notice these two formulas. If you interchange the a and the b, you have the same formula. It really makes no difference. Okay. The one that's very picky is the c. All right. So x is a, so I'm using this version of it. I got x squared is c squared minus b squared. Here's my b. Here's my c. And again, I'm just walking the dog at this point. I often say, you don't do mathematics, right? Mathematics has been around for a very long time. You just supervise it, right? The formula does all the work for you. It's the beauty of the Pythagorean theorem, and I think theorems in general, they're always true. Yeah. So 19 squared is 361, 13 squared is 169. So this is true already. You don't have to do anything. You just have to supervise it, make sure that it remains true. Let's see. So I got 361 minus 169 is 192. So x is the square root of 192. I like to put that in my notes so I know that I killed the exponent. So x is approximately 13.8564, round to the nearest tenth. So the dictator is the hundredth. Now that is greater than 5, 5 or greater. That's the rule, the 5 or greater rule. So we're going to round it up to 13.9. Yep. So the 5 rounds up. Round up. And then you throw it away after you've rounded it up. So you add 1 to the 8, becomes a 9, 13.9. All right. So, again, I wish I could ask if there were any questions. You could write your questions down if you have them. Let's get into some applications. Our people that came before us were not just, there's two types of math. There's the type that's simply abstract. It's really what Pythagoras was. A philosopher, just cared about the abstract concept of mathematics. But there are other people like engineers and scientists of many sorts, and even just people doing common jobs. I'm going to use a sports analogy. A baseball diamond. This is a professional, so major league, not little league. The distance between each base is 90 feet. Let's put FT, 90 feet. What is the distance from home plate, some people call it home base, but it's home plate, to second base? All right, so this is a Major League Baseball diamond. The distance between each base is 90 feet. We call it a diamond, but it's really a square. But that would just sound funny to call it the baseball square. All right, so here's home. Here's first, second, and third. All right. I guess the pitcher's mound is right here in the middle. And I want to know the distance from home plate to second base. So if you were the catcher, you had to throw the ball all the way to second base. Remember, the distance between each base is 90 feet. 90, 90, 90, 90. All right. And this is a right triangle. Right? These are 90-degree angles in each corner. Okay. Now, I don't need to use both of these 90-degree angles. Just pick one of them. All right. So I'm going to go ahead and pick this one. This is sometimes called dissection or dissection. We've done this before, where we take a geometric shape and we cut it up into smaller shapes. So this is 90 feet. This is 90 feet. Sorry, the drawing is awful. Let me try that again. There we go. And again, you don't really have to redraw this. I just want to make it clear that I'm cutting off half, so I don't need this side of the diamond. I'm just taking only half of the diamond. I want to know this distance here. So I'm trying to find x, the hypotenuse. All right, so we have our formula. X squared is 90 squared plus 90 squared. I should do that in my head. It's 8100. If you don't believe me, do it. 81 times 81. Sometimes 81 times, 90 times 90. I don't know. 90 times 90 is 8100. I almost did 81 times 81. It's 90 times 90. Now I'm going to add the 8100s to each other. So that's 16,200. And then I'm going to take the square root. Always do that at the end, canceling out the exponent. Let's see. Let's round to the nearest tenth again. I should read that at the beginning, but it's better to know what you're doing before you actually finish the problem. So the square root is 127.279. So my dictator is the 7. So I'm going to throw it away and round this up to a 3. So it's 127.3 feet. 127.3 feet. That's a long throw. Any of you played baseball? If you played Little League or something, it's a little bit smaller. I think it's 60 feet. All right, so that's one example, the sports example. Football doesn't really make for a good Pythagorean theorem problem because it's difficult to imagine a triangle. I mean, I could probably make something up if I really wanted to, like where the quarterback throws the ball diagonally or something, but typically baseball makes for a good Pythagorean theorem because there's a natural triangle already inside of the diamond. Okay. So most of these examples are ones in life or in imaginary life where we have a natural triangle that's being made already. One thing that I do when the weather is nice, especially lately, is hiking. Suppose you go for a hike. Now I'm going to keep this really simple. This is a real boring hike, maybe in the desert. Yeah. So I'm not going to go up a mountain or anything like that. We'll assume it's flat. You hike 8 miles south from your home. So maybe you just. I grew up in Desert Hot Springs many years ago in the 1970s. It was a lot of open desert, and when I was a little kid, I could just walk right out of my front door and right out into the desert. So maybe I'm having a childhood flashback. Then you turn west and hike for another 3 miles. What is the shortest distance directly back home? All right. Now remember, north is up. Yeah. So just keep that as a reference in your mind. Typically when we draw maps, we put north towards the top of the map. Not always. There are some strange maps where north points in a weird direction, but I'm not going to make it more complicated than it needs to be. So let's read the question carefully. 8 miles south, and then you turned west and hiked another 3 miles. So 8 miles south, MI for miles. Yeah, so here's home. And then you turned west. Easy way to remember, west is left. Yeah? Well, if north is up. Yeah? East is right, and north is up, south is down. So 8 miles south, and then you turned west and started heading 3 miles. What is the shortest distance directly back home? All right, the shortest distance directly back home. So you just went across the desert diagonally all the way back to your house. Okay, so again, that's X, or you could call it C. You know what? I wouldn't know. If you want to look at the first, 3 examples that I did, that pretty much summarizes the entire lesson, and you can just always use the letters A, B, and C. So we're looking for C, essentially. And so what do we have? We have X squared equals 8 squared plus 3 squared. These are mental math. 64 plus 9. X squared is 73. 73. Square root both sides. Square root of 73 is approximately 8.544. Let me read the question. Round to the nearest mile. I do occasionally get emails where a student feels like they did it right, and they'll be like, Dr. Jordan, I keep doing it and marking it wrong. And I go, did you read the directions carefully? Hopefully. I often forget. I know I often forget to write them down, but then I make sure I read them before I submit. So to the nearest mile, so that means the dictator is the 10th. All right, so X is approximately 9 miles. 9 miles, because that's a 5, so we're going to round the 8 up. Yeah. And then throw away all the decimals and round the 8 to a 9, so approximately 9 miles. And that's a big round when you go from 8.5 all the way to 9. If I really wanted to be more precise, I would just say 8.5 miles, but I'm just following the directions. I'm not really thinking too far into it why I would do that, just because it says to do it. How much time we got? I can't tell how long we've been going. Well, hopefully it's not too long. A few more examples, a few more application problems. And if this video gets on too long, I'll stop it and do a part 2 so I don't exhaust your brain too much today. 10 or 11, maybe 12 examples is probably plenty. Oh, I love this one. I learned this one when I was a kid, the firefighter. A firefighter must enter a house. Let's call it a burning house. Through a window. At some point I thought about having all these typed out already and like holding a thing out. I have done that on more complicated ones, but I actually like the process of writing and thinking as I'm writing. Remember, read, and then read it again, translate it, solve it, and then maybe check your answer. Been a little bit lazy on the checks because this is homework. You're going to be doing this in the homework. When it gets more high stakes, quiz or a test, you definitely should be checking your answers. So burning house through a window on the 2nd floor. Let's say 20 feet above the ground. There's a bush at the base of the ladder. So it must be placed 4 feet away from the house. What is the shortest possible ladder that can be used, that must be used to reach the window? Now, there's a lot of ambiguity here. Of course, I mean, you could go farther than that, but I'm just making it very straightforward. You have a window, right? There's the window. You got a bush. Okay, there's the bush. I know it doesn't look like a bush, but whatever. There's a bush right here. Okay, and then the ladder is going to go right to the base of the window. So this is my ladder. All right, and I'm assuming the house is 90 degrees. It's, all right, otherwise the house will be leaning like this. So this is a right triangle. All right. Forgive my drawing. It's not the best drawing, okay? But you get the idea. All right. So read it. Maybe draw a picture if necessary. Sometimes the picture comes with the problem. I would abstract this a little bit and just draw it as a triangle like this. This is 21 feet. That's how high the window is. And the bush is 4 feet. So that's my A and my B. Yeah. And then the ladder is the C or the X. All right. So you have C squared is 4 squared plus 21 squared. 4 squared is 16. 21 squared off the top of my head, I don't know it. 441, I probably gave up a little too quick on that one. 441. Plus 16. 457. And then square root. C is approximately 21.37. Round to the nearest tenth again. This is tenth. Tenth of a foot, which is weird. A tenth of a foot is, what's a tenth of a foot? 12 divided by 10. 1.2 inches is a tenth of a foot, but you don't typically measure feet in tenths. But anyway, I'm pretending that we're measuring it in tenths. So we're going to cross off the 7 and round the 3 up to a 4, 21.4 feet. 21.4 feet would be the minimum length of a ladder in order to reach the base of the window. Okay. What else? What else? Maybe I'll do one more. I feel like we've gone on quite a bit. You might notice there's not a lot of variety in this first part of the lecture. There will be some more variety in the second part. Maybe I'll stop at example 12. So I got 2 more. If you can hang in there for another minute. If you feel like you already got it, you know, I'm not enforcing. You know, this is all for your benefit. Televisions, all right? Televisions, TVs are measured by the diagonal length. I'll just say the diagonal length across the screen. I'm probably spelling across wrong. I always put too many C's. Is it just one C? Across the screen. All right, so this is how you measure a TV. If somebody says, you know, how big is your TV? They say it's 42 inches. We're always measuring the diagonal across the TV screen. And now that we have the big flat screen TVs, they've gotten a lot bigger than the old 1980s, you know, big back televisions. All right. So suppose your TV is 40 inches. IN for inches wide, and 28 inches tall. What is the size of your television? So what size TV is this? And I'll put the word size in quotes. So if you go to Best Buy or Walmart or wherever you buy televisions, Target, whatever, and you want to buy a new television, and it says it on the box, however many inches it is, this is what they're measuring. Even though these are the 2 things that you actually probably would see, you know, in your house if you were installing it, you know, these are the 2 important numbers, but those numbers typically are not in the box. Sometimes they'll put it in the fine print, you know, if you read the fine print, but typically on the big number that's on the front is this number here. Okay, and again, you can call it C or you can call it X. You can call it whatever you want. All right. Although I wouldn't use A or B for that. Remember, A and B are always considered the legs. So you can call the hypotenuse X or, you know, S for size. But the most common letter is probably C. So again, notice this is the same formula over and over and over again. 40 squared plus 28 squared. I'm using my calculator here, 1600. That one's easy, 40 times 40. 28's not so easy. It's 784 plus 1600, 2384. So the square root of 2384. And we get C is approximately 48.82, round to the nearest inch. Inch is a whole number. Typically, you go to a television store, they just say, you know, 48 inches or 49 inches or whatever it happens to be. This is sort of a strange size. I don't think I've ever seen a television that size, but it would be approximately 49 inches. I've actually never seen a 49-inch TV, but there could be one. Yeah. I know they have 50s. Yeah. I remember back not so long ago, my kids were little, maybe 10 or 15 years ago, my kids were little, we got our first 32-inch TV back in the early 2000s. And that was a big deal in our family. A 32-inch TV, it was like, wow. I never, and now it might, kids would complain if they only had a 32-inch TV. But are you guys spoiled on your TVs? Anybody out there got a 60 or 70-inch TV? I don't know. Got it too easy these days. Especially we've been home for the last year and a half, probably watching way too much television. I think I can squeeze in one more. Yeah, I got one more. This one's a little tricky. I saved the trickiest one for last. This one's a straight word problem. The shortest side of a right triangle is 11 inches. The difference between the lengths of the other sides is 1 inch. Find the length of the missing sides. I sometimes use the term missing to mean unknown. Yeah. I don't really particularly like the word missing because it makes it sound like it's actually missing, but it's not really missing. It's there. It's just unknown, but it's still there. But I'm just following the terminology that's in the book and very common terminology that you have. All right, so when you have a straight word problem like this, doesn't come with any accompaniment, there's no picture, you should be reading. Yeah, read it, draw a picture, that's very important. Translate, yeah, use the Pythagorean Theorem or whatever section we happen to be covering at that time. Today it's Pythagorean Theorem. And then solve the problem, and then possibly for this one I will check because it is the last one, and it's really easy to check these kind. Some of the other ones were, it's either right or it's wrong, and so the easiest way to check those ones is just to plug it in and see if it's right. This one you can actually look over it and make sure it's correct by simply going back to the beginning and reading it again. All right, so read. Okay, I'm reading it. The shortest side is 11. So that looks like A. A is 11. If I draw the triangle in this orientation. If I drew it upright, then I would make 11 be the base. If I drew a triangle like this, okay? It's your choice, right? You don't have to do both. I already made my choice, so there it is. That's 11. This is B, and this is C. All right. I like to highlight as I read the difference between the lengths, there's an S in there, of the other two sides is 1 inch. So difference means subtract. Okay, so C minus B is 1. Yeah. And it has to be C minus B because C is longer than B. Right? So this order matters. Be very careful. Difference is ambiguous. It just means to subtract. Right? So you need to know, you have to subtract, the larger one minus the smaller one. Otherwise, you wouldn't get a positive number here. Okay. All right, and then you got my favorite version of the formula from the very beginning. You have C squared equals B squared plus A squared. That's my favorite version. I'm ending the lecture today with exactly what I started with. C squared equals B squared plus A squared. All right, I know A. That's easy. It's 11. Okay. So now I'm translating. That's my translation. I'm wishing I had some more room. Let me just slide over a little bit. Slide over here. So I've got C squared equals B squared plus 11 squared. I'm just sliding over here so I can work. So I've got c squared is b squared plus 121. Now I need to use this, okay? Now I don't know what c and b are, but I have what's called a relationship. Yeah. In fact, if you have been listening to my rants sometimes on these videos, and I probably did it more often back in person because, be in the classroom every day and, having to tell stories and stuff live, I would often tell my students and just people in general, in fact, they ask, oh, what is math about? What do you... And I say, math isn't really about numbers. Math's not really about equations. Math is about relationships, understanding how things are interconnected, understanding what the relationships between things are. And those things happen to be numbers in this particular, or geometry, geometric shapes, but it's the relationship that matters. So this tells me something about c and b. It tells me that their difference is 1. So if I add b to the other side, yeah, I get another relationship that says c is b plus 1. Yeah, b plus 1. Or I could say 1 plus b. It means the same thing. Right. So this is what we call a substitute. Now we are really getting into algebra here. It's called a substitute. In the next course, maybe Algebra 1 or Algebra 2, intermediate or another level, sometimes college level algebra, we do a lot more detail on these types of problems. I'm just kind of barely scratching the surface here. So I'm not going to give a huge lesson on substitution method. But if you've seen it before, it's very common in a first-year algebra course. So we're starting to branch out of the pre and into the algebra. So I'm replacing what used to be c with b plus 1. So now I have b plus 1 squared equals b squared plus 21. So I'm kind of cordoning off. This is my workspace over here. I'm running out of time. I'm running out of space. I've got plenty of time, I guess. So where should I go? I'm going to move over here. So I've got b plus 1 squared equals b squared plus 21. My diagram is taking up too much space. So this is b plus 1 times b plus 1. That's what squared means. Now this is kind of new for this class, but we're getting very close to the end, so this type of thing is going to come out. You're going to multiply b plus 1 times b, b plus 1 times b, 1 times b, and then 1 times 1. All right. This is sometimes referred to as FOIL, and I'm not going to get into the details today. So that's b times b is b squared. B times 1 is 1b. Another b times 1 is another 1b. Some people omit the 1, but I'm not going to. You'll see why in a second. And then 1 times 1 is 1. If you haven't seen this before, this is new. This is sometimes called FOIL. I will give an entire lesson on that in the future. Today I'm doing just an introduction to the concept. All right. So if it freaks you out, or if it's familiar to you, I don't know. There's lots of different feelings that people have when they see this. So now I've got b squared plus, and this is the reason why I like to write the ones here. 1b plus 1b is 2b. I'm going to go ahead and erase my triangle now. It's getting in the way. All right. Now remember, I'm trying to find b. All right. So I'm going to get rid of the b squared by subtracting it from both sides. And that cancels out the b squareds. All right. I'll give you a hint on this type of word problem. If you still have a b squared when you get to the end, you definitely made a mistake. All right, I made all these problems, at least this type of problem, I made them all so that you get a nice simple equation that we already knew how to solve. Because I don't want to get into the details of how to solve them in the more complicated sense. That's a lesson for another course, in fact. That's the next level. All right, so you know how to solve these, right? We call this walking the dog, right? Move everything over to the other side. So you're going to move the 1 over. Subtracting 1 from 21 gives you 20. And your last step, divide both sides by 2. And there's your final answer. B is 10. So these problems can be complicated, but they should give you a very simple answer. Now, that's my hint when you do this in your homework, or if it happens to show up as a quiz question. This would probably be in the realm of extra credit. I don't know. I shouldn't say that quite yet, but if it were on a test, this would definitely be a more challenging problem. In the homework, you could try it as many times as you want. All right, so you know B is 10. All right, so that's the longer leg is 10. I think they're inches, yeah. And then the hypotenuse is the longest side on the entire triangle. We don't call it a leg, though. It's going to be 1 more than B, so that would be 11 inches. Just by looking right here. If B is 10, that's your B. And then C is, the hypotenuse is 1 more, yeah? Hypotenuse is equal to 1 more than whatever B was. And there you go. Before I stop the video, I will check this. The shortest side is 11. The difference between the lengths of the other two sides is 1. Hey, it's an isosceles triangle. This is a little bit misleading because I said the shortest side. There actually are 2 shortest sides. I mentioned that at the beginning of this lesson. I said towards the end we might get into what are called isosceles triangles. An isosceles triangle, I think we saw one earlier actually. The baseball diamond is also an example of one. We have an 11. Huh. 11, an 11, and a 10. I'm confused now. We should check that. So 10 squared plus 11 squared equals 11 squared? Something's wrong. Something went wrong. I'm regretting this problem now. C is B plus 1. Ah! Somebody almost got extra credit. It's 121, not 21. Whew. I was sweating it for a second there. When I rewrote my problem, I accidentally wrote 21. Whew. Saved by the bell, I guess. So 121 minus 1 is 120, and then divided by 2 is 60. So the longer leg, so it is not an isosceles triangle. Sorry about that. But you know what? As I mentioned earlier, I make mistakes. Everybody makes mistakes, and now you learn from my mistake. When you copy something down, make sure you copy it correctly. And I'm glad I checked. I wish I could say I planned that screw up to kind of motivate you to check your answer. When I first drew it, this just didn't make any sense. It's not an isosceles triangle. We will be talking about an isosceles triangle. I'm going to have to put it in part 2. So let's go ahead and check. The hypotenuse is 61. The shortest side is 11. And then the other side is 60. And so when we check, we should check that 60 squared plus 11 squared is 61 squared. So let's do that. 60 squared is 3,600. 11 squared is 121. And 61 squared is 3721. Check. That's true. 3,600 plus 121 is in fact 3721. So this is correct. I'm glad we checked. So I will say, I wish you all the best. Good luck. Come see me on my office hours if you need me. But until the next time, this is Dr. Jordan. I'll see you on the internet.